Hello, let's continue our Sudoku adventure with Unique Network by Pewter Bleep and GDC. So this begins our theme week, which is also, it's going to go Tuesday to Monday this week because I forgot to start it on Monday, but here we are. So our theme this week is extra regions. So there's just going to be some kind of extra region constraint in each of these puzzles. A region is just a set of 6 cells that can't repeat digits. And so like a row, a column, a box. And so in this puzzle, for example, the circles are an extra region, meaning that we're going to put 1 to 6 once each also within those circles. No repeats. All right, well, let's go over the rules. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have what are called double arrows in the grid. I think it's a poor name, but it's based on the fact that arrows are a circle with an arrow coming out, and how they end in another circle instead of having an arrow tip. So they really shouldn't be called arrows. But anyway, maybe double sums. It doesn't matter. That's just the name that Zeta Math came up with when he invented them. And so that's its name. All right. Anyway, the way they work is the 2 circles add to the same amount as the attached line. So if this was, for example, 3 and 6, that adds to 9. This would also add to 9. So we could, for example, do 1, 2, 6 here. So 1 plus 2 plus 6 is 9, 3 plus 6 is 9. This would be fulfilled. All right. In addition to that, all of the circles form an extra region. So we are putting 1 to 6 exactly once each in those circles. No repeats. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. I think the first thing I'm going to do is I'm going to assign a different color to each of these circles, because we know that they are an extra region. And so it can help with finding like interesting geometry, perhaps. All right, so we have, let's see, do we have any geometry? Like this yellow accent. So the double arrows where there's just a single cell on the line are a bit special because you can especially restrict them. So, for example, we know that this can't be yellow. Imagine if it was yellow. How would we make yellow plus red equal yellow? The only way is if red was 0. We don't have 0. So yellow isn't repeated in the column and yellow is not here. So I guess yellow is one of these two. I wonder if I can get like a really good geometric deduction from all this. We know that green is on this line here. I'm actually going to mark that. So whatever green is, it's part of this 3-cell sum. This maxes at 11. If this was a 5-6 pair, this would be 11. Oh, but okay. So we can't actually put 6 on these, though. Again, these are special, and I didn't finish saying why they're special, but imagine one of these was a 6. What that means is that 6 plus something equals this digit. So this is always bigger than both of these, right? This is the sum of both of these, and there's no 0. So this is strictly larger, which means that both of these are smaller than this, meaning they can't be 6s. So this is all of these are part of a 1-cell sum except for green. So I guess green is 6, meaning there's a 6 in one of these 3. So, okay, so the biggest this could add to is 9 then, because they could be a 4-5 pair adding to 9. The minimum this is, because it has a 6 on it, is 1, 2, 6. So that adds to 9, meaning this has to be a 4-5 pair. And so now these are the remaining digits, 1, 2, 3. Okay. I'm going to keep the green, but I'm not going to green over here anymore because I know it's a 1, 2, 6 triple. So this is a 1, 2 pair. And these are from 3, 4, 5. So I'm going to mark that. So this, ooh, interesting. Yeah, so, how am I going to get this to work? I don't think this can be a 3. If you think about it, if this was a 3, the 1, 2 pair makes up for that 3. That gives us our 3. But then this would have to be a 6 in order to get us to the correct sum. So basically, an easier way to put that is we know this adds to 3. So our sum is either 6 or 7 or 8. Our sum can't be 6, so this isn't a 3. Our sum can be 7, 6 plus 1, and our sum can be 8, 6 plus 2, but that means this isn't a 3. That means one of these two is a 3, making this at least 4. Okay. This, at minimum, is 5. This is 5 or 6. Oh, it can't be 5 because of the 4 or 5 pair. So this has to be 6, because 1 plus 4 is the minimum I could do. But we can't do 5, and so it is 6, meaning we're 1 plus 5 or 2 plus 4. This is a 1-2 pair, so actually, this is the yellow or blue. That's 1-2 over here, but that means this is purple. Purple's down here. I don't know if I need to color too much anymore. This is a 1-2 3. Wondering about yellow. Oh, yeah. So this has to be yellow, because yellow can't be this 6. In fact, this is green. So we're down to yellow and blue, and this yellow looks up. So this is blue, and this is yellow. That means that's not yellow. Okay. I need a 6 down here somewhere. 1, 2. Well, this is at least 4. Hold on. This is definitely a 1. It's connected to a 4 or 5 pair, meaning it will be connected to a 5 to create a single cell sum. This can't be 6, though. So this is our 6. Gives us our 5, 4, and 1, and that's our 5. Okay, I hope you followed that. Let me go back and explain that a little bit better. This is a 4 or 5 pair, meaning this has to be a 1, because if it wasn't a 1, I'd be adding 2 plus 5 or 3 plus 5 to get a 7 or an 8 over here. So that's not going to work. So first of all, this is a 1. That makes that a 1. You can clear these out. That makes this a 1, and it's yellow. All right. So we're taking this a little bit more slowly. And so now, oh, and that makes this a 2, and that makes that a 2, and that's a 1, which makes that yellow. This is 3. All right, it actually cascades pretty well without even that logic. 3 plus 1 is 4. But I do want to show that logic, so we'll show it right now. This can't be 6, because there's a 6 in the box and a 6 in the column. So this maxes at 5, meaning we have to do 1 plus 4 is 5. So that's 5, and that's 6, and that makes this 4 and that 5. All right, so this is red, and this is orange. Gives us the 2 and 6 here. Yeah, I will finish the colors because I've started them. I just need to get these colors. We know all the colors. This is purple. This is orange. We have digits for everything. Sorry, I'm just not going to finish the coloring because it will double the time of this puzzle. I need 2 and 4 here. So this is 2. This is, oop, misclicked. That's 4. This column finishes with a 5. This is a 2. This is a 6. Kind of wondering if I needed the colors at all. 1 in the box goes here. This is 3. All right. So up here, I need 2, 3, and 4. This is the 2. This is the 4. This is the 3, giving us 5 and 4. I suppose I could have known that this adds to 8, meaning this is 1, 2, 5. All right. 1, 5, and 6 down here. So this is the 5. This is the 1. This is the 6. All right. Neat puzzle. Nice collab from Pewter Bleep and GDC. I enjoyed that. Seems like the key deduction to get started was that none of these could be 6. So I placed the 6 here, put a 6 on here, which actually minimized it to 1, 2, 6. And from there, I think the last thing was noticing this 4 or 5 pair forced this to be 1, and that to be 5, and that to be 6. Once you had that, the whole thing just collapsed. So it seems like you really didn't have to color at all. I think the colors just got in the way. I thought it might be a coloring puzzle because of the extra region, but it wasn't. All right, cool. Well, let me know how you did, and if you enjoyed this, want to leave a like, subscribe, and a kind comment below.